This classwork begins with simplifying rational expressions, where in the first expression I have x minus 12 over x minus 12. Whenever I have something over itself, that just reduces to 1. For the second part, I have x minus 12 over 12 minus x. What I can do here is I can leave the top as x minus 12. On bottom, if I want to switch the signs on these, what I'm really doing is pulling out a negative 1. When I factor out a negative 1, that positive 12 becomes a negative 12. That negative x becomes a positive x. So I really have x minus 12 over x minus 12 times a negative 1. If I get rid of these factors, x minus 12 and x minus 12, there's an understood 1 in front of this. There's a negative 1 in front of this. So I really get 1 divided by negative 1. If I were to put that in my calculator, 1 divided by negative 1 just gives me negative 1. So here, when I have x minus 12 over the reverse of that with the signs, it ends up just being equal to negative 1. Here, when I have x minus 12 over itself, it ends up being just 1. So these things are going to happen in much larger, harder problems, where basically we're going to be looking for when the same factor appears on top and appears on bottom. If they're identical, we can cancel the top and bottom and just call it 1. If they're very close to identical but off by a negative sign, we can cancel top and bottom and keep that negative in the problem. Here, when I have just x minus 12 over 1, it'd be the same thing as having like 5 over 1. I could just write that as 5. This I can just write as x minus 12. Number 2 asks me to evaluate the expression for x equals 5. All that means is plug in 5 and find an answer. So if I plug in 5 wherever I see an x, it becomes 4 times 5 plus 1 over 5 plus 2. Remember that there's understood parentheses around the top and bottom of a fraction. I have to combine everything on top, combine everything on bottom before I can do division. Now when I say combine, I have to turn it into a multiplication problem basically. So when I have factors, things down here that are going to involve two factors being multiplied, I can keep those things multiplied. I don't have to do the addition. But here, when I have to start by doing 4 times 5, which is 20, plus the 1. On bottom, 5 plus 2 gives me 7. When I do 20 plus 1, I get 21 over 7. And really, 21 over 7 reduces to 3, which is my final answer to evaluating this expression for 5. But notice I didn't do the division until I had the whole top complete and the whole bottom complete. The main types of problems you're going to see in this section are these simplify the expression problems. It always is going to tell you assume the denominator is not equal to 0. They have to say that because if the variables made the denominators equal to 0, then you would end up getting something that is not able to be done in math. You can't divide by 0. So we're always assuming that the bottom is not 0. The first couple problems might look a little similar to things we've done previously in dividing monomials and rules of exponents. But when we get down to things like E and F and the other things that are going to be on the next board, you'll see how factoring factors in. Here, when I have 4x over 5x, really, I can just say this is x to the first over x to the first. 1 minus 1 will give me x to the 0 or no powers of x. So these x's are going to cancel each other out and just leave me with the 4 on top, 5 on bottom. Here, when I look at b, I start with the coefficients. 30 divided by 5 gives me 6. When I then look at the first variable, x to the third on top, x to the second on bottom, 3 minus 2 gives me x to the first. When I look at the second variable, the y's, 2 on top, 5 on bottom, that becomes y to the 5, or I'm sorry, y to the 2 minus 5. 2 minus 5 is negative 3. I cannot enter an answer like this because I cannot have a negative or exponent in my answer. So I need to write this as the part that's staying on top, 6x, over the part that moves to the bottom, y now to the positive third. The other way of seeing this is back in this step, when I had y to the second on top, y to the fifth on bottom, I really had 3 more y's on bottom. That's why in the final answer it stays as 3 y's on bottom. So I don't always need to bring it to the top as a negative, then take it back down. That's really 2 steps instead of 1. If I can just look at each variable and say, where is there more of them and how many more? There's 3x's to 2, there's 1 more on top, so 1 more stays on top. There's 2 y's to 5. There's 3 more on bottom, so 3 stay on bottom. You can definitely apply that kind of logic. In part C, I need to figure out what I can factor out of the top that then can be reduced on the bottom. 12x and negative 10 have a greatest common factor of 2. If I factor out that 2, 12x divided by 2 gives me 6x. Negative 10 divided by 2 gives me negative 5. On bottom, I always had this 2 being multiplied by this y. So if I reduce by 2, it leaves me with a final answer of 6x minus 5 divided by y. Same idea here in D. I see that the top, I can pull a 5 out of the top 2 numbers. If I pull out that 5, 25x divided by 5 gives me 5x. Negative 10 divided by 5 gives me negative 2. On bottom, I always had a 5 being multiplied by y. So when I get rid of those 5s, I'm left with 5x minus 2 over y. And when I say get rid of, let me be clear that what's really happening here is I'm dividing something by itself to just equal 1. But if I do 1 times this top, this is what I get. If I do 1 times this bottom, this is what I get. Just be aware that there's going to be situations where a 1 is left behind and you don't want to say 0 is left over there. When I get down to E and F, these are ones that require higher level factoring on both the top and bottom, and then seeing which factors are the same on top and bottom, reducing them in the same way we reduce these 5s or these 2s. So let me show you what I mean. X squared minus 36 is a difference of squares. I can factor it as x plus 6, x minus 6. On bottom here, I have a perfect square trinomial. If I set up my 2 parentheses, put in x and x, first sign's positive, second sign is the same, so also positive. I'm looking for ways to multiply to 18 and add to 9. So the ways to multiply to 18 are 1, 18, 2, 9, and 3, 6. The one that adds to 9 is 3 and 6, so I'm going to put the larger one here, the smaller one here. I now have fully factored the top and bottom of the problem. At this stage in these types of problems, I need to say, is there any repeated factor that appears on both the top and bottom? I see that this x plus 6 appears on both the top and the bottom, so I can reduce the top and bottom by an x plus 6. When I do that, what's left behind on top is an x minus 6. On bottom is an x plus 3. For problem F, I need to apply the same math, but first I need to figure out what's going on bottom. So on bottom, I have 2x minus 1 minus parentheses x plus 4. I can rewrite that as 2x minus 1, just dropping the parentheses because there's nothing being multiplied. Then this negative I can apply to x as a negative x, and the negative I can apply to 4 as negative 4. When I now go to combine like terms, 2x minus x just gives me 1x. Negative 1 and negative 4 combine to give me negative 5. On top, it's a factoring problem. So what I need to factor has an x squared as its first term, meaning I have x and x. Has a negative as its first sign, which I'm going to put into the first parentheses. This tells me same sign, so I'm going to put another negative in the second parentheses. I'm then looking for 2 numbers that multiply to 20 and add to 9. The ways to multiply to 20 are 1 times 20, 2 times 10, and 4 times 5. When I add 1 and 20, I get 21, 2 and 10, 12, 4 and 5 does give me 9, which is what I was looking for. So I'm going to put the bigger one first, the smaller one second. As you can see, I have an x minus 5 on top, as well as an x minus 5 on bottom. I can reduce by getting rid of these factors. Really, it turns into a problem like this, where I have something over 1 now, because this x minus 5 leaves behind a 1. But whenever I have anything over 1, I can just write it as itself. So x minus 4 over 1 can just be written as x minus 4 as a final answer. Part G asks us to take x minus 8 over 8 minus x. This refers back to the idea of taking negative 1 out of the bottom here. If I leave the top as x minus 8, really being multiplied by an understood 1, and I make the bottom -1 pulled out, that'll turn this positive 8 into a negative 8, and this negative x into a positive x. I then can see x minus 8 and x minus 8 is the same factor top and bottom, which means I can be left with 1 over -1, which just equals -1. In problem H, I have a similar thing going on bottom here. I can make this bottom into -1 times x minus 6. On top, I can pull out 7 from each of the terms. 7x divided by 7 gives me x. -42 divided by 7 gives me -6. I can now see that the -6 is the same factor on top and bottom. I can reduce it, which leaves me 7 on top, -1 on bottom. 7 divided by -1 equals -7. In part I start with the 12 being divided by 3. 12 divided by 3 gives me 4. I have 2 x's on top, 1 on bottom. 2 minus 1 leaves 1 on top. 2 y's on top, 1 on bottom. 2 minus 1 leaves me 1 y on top. I technically could put this over 1, but I don't need to have it divided by 1. Everything on bottom reduced, and when I divide something by 1, I end up just writing it as the number anyway, or in this case as 4xy. In part J, I need to combine the top before I do the division. So when I do 3x plus 3x, that gives me a total of 6x. When I divide 6 by 2, I'm left with 3x. So I can't do the division separately here without delving into the world of fractions or decimals. You're definitely better off trying to combine the like terms on top first and then doing the division, even though it is valid to split this and make it each over the 2. In part K, we have another one of those circumstances where I have to factor, in this case, both the top and the bottom. So I'm going to put 2 parentheses on top. I'm going to put 2 parentheses on bottom. For the top, I have the x that tells me I'm going to put in x and x. I have the first sign being negative. I have the second sign telling me different from the first sign. Different from negative is positive. I then see a 24 subtracts to 2. So the ways to get to 24 are 1, 24, 2, 12, 3, 8, 4, 6. The one that subtracts to 2 is 6 minus 4 is 2. So I put the larger one here, the smaller one here. If I do the same thing for the bottom of the equation, x squared minus 3x minus 28. I'm going to start by putting in x and x. I'm going to take the negative sign, put in the first parentheses. This tells me different from the first sign, different from a negative is a positive. I'm now looking for something that multiplies to 28 and subtracts to 3. The ways to multiply to 28 are 1, 28, 2, 14, and 4, 7. 28 minus 1 is 27, 14 minus 2 is 12, 7 minus 4 is 3. So 7 minus 4 gets me to what we want as the middle term. I put the larger one here, smaller one here. I now see that I have x minus 6, x plus 4 on top, x minus 7, x plus 4 on bottom. The repeated factor is this x plus 4, which I can reduce on top and bottom. That gives me my final answer of x minus 6 on top, x minus 7 on bottom. Finally, problem L. I start off by making my 2 parentheses, top and bottom, put in x and x, bring down this first negative sign. That second sign tells me same as a negative sign is another negative sign. I'm now looking for 2 things that multiply to 16 and add to 10. Well, the ways to multiply to 16 are 1 times 16, 2 times 8, or 4 times 4. When I add them together, 1 and 16 give me 17, 2 and 8 give me 10, 4 and 4 give me 8. So I want 2 and 8 that give me 10, larger one first, smaller one second. When I go to do the bottom, I put in my x and my x. First sign's negative, second sign is different from a negative is a positive. I'm now looking for 2 things that multiply to 8 and subtract to 7. So the ways to get to 8 are 1 times 8 and 2 times 4. 8 minus 1 is 7. That's what I'm looking for. Larger one first, smaller one second. I now can look top and bottom and see the repeated factor is x minus 8, which means my final answer should be what's left over, x minus 2 on top over x plus 1 on bottom.